Hello everyone. In this video, I will explain column chromatography, definition, principles, how to use it for the effective separation of chemical mixture, and what are other applications of it. From the definition, it's a chromatographic technique used for the quantitative separation. Please note this point is a quantitative separation. It is different than TLC and paper chromatography wherein they were used for the qualitative detection or qualitative separation. That was not quantitative. So it's used for the quantitative separation of chemical mixture into individual components using column. And principle is similar to what we have seen in TLC. Components are separated based on their affinity towards the mobile phase as well as stationary phase. This is how a column looks like. From the distance we may see it like a burette, but it is not burette. It doesn't have any graduation, most of the columns. So it contains long glass tube. It's called column, and at the end you will be having stopcock, and another end you will be having solvent reservoir. Notice this, not necessary that you will be supplied with this. Sometimes column comes only up to this. You may have to attach this solvent reservoir, but actually it is not needed. You can just pour the solvent from the top directly to this. No need of this separate bulb here, which is called solvent reservoir. Earlier, long ago, this used to come along with the column, but nowadays it comes only up to that. So you can put a pressure here even with the bulb after putting the solvent, so that you can make this movement faster. Okay, this column will be fitted with the components, I mean other stationary and mobile phase. So this at the end you have to put a cotton plug before loading the silica gel, otherwise silica gel will be leaked out. So put cotton plug, then you pour the silica slurry here, then put the chemical mixture at the top. After that you can put a sand here if needed, not necessary, or you just put another cotton plug here, so that after pouring the solvent your chemical mixture should not come back, it should go down. That's the main purpose of putting the sand or a cotton plug here. Okay, this is what normally looks like. Then very important point is experimental setup. So how you set up the column for the better separation. So after choosing the proper mobile phase and proper stationary phase, so set the column and then you put the sample, then you start doing the addition with the appropriate solvent, then components will be separated. You can watch these videos for better understanding.
Hey everyone, quick biochemistry basics here. Let's talk about column chromatography. Column chromatography is a chromatography technique in which separation is carried out in column. The column is filled with a stationary phase which can either be silica, alumina or cellulose. The bottom of the column is packed with cotton or glass wool to support the stationary phase. The column preparation is usually carried out by two methods. Number 1, wet method, and number 2, dry method. In wet method, the stationary phase is mixed with a mobile phase to make a slurry and then packed in the column. In dry method, the powder of stationary phase is directly added to the column. Once the powdered stationary phase is packed, the mobile phase is flushed in the column to make it wet. Now, any of the method can be used for column preparation. However, care must be taken to avoid any bubbles in the column while packing the stationary phase. Let's see the working of column chromatography. The sample is loaded with the mobile phase on the top of the column. Once the sample is loaded, the mobile phase is continuously passed to cause separation. The mobile phase moves down the column because of gravity. Separation of molecules occur due to their differences in interaction with the mobile phase and the stationary phase. For example, the green molecules interact more with the mobile phase and moves fast down the column, while the dark blue and the violet molecules interact more with the stationary phase and hence move slowly. To increase the flow rate of the mobile phase, a pump or pressurized gas like argon or nitrogen can be used. Once the separation is completed, the samples are usually collected as fractions. The mobile phase leaving the column is known as eluate, while the sample molecules leaving the column is called eluite. Now, depending on the type of stationary phase used, there can be several types of column chromatography. If the stationary phase is adsorbent material like alumina or silica, then it is known as adsorption chromatography. If the stationary phase is ion exchange resin, then it is known as ion exchange chromatography. If the stationary phase is attached with a ligand that binds a specific molecule such as protein or enzyme, then it is known as affinity chromatography. And if the stationary phase is a porous gel or bead, then it is known as gel permeation chromatography.
This video outlines a method for carrying out column chromatography. You may be given slightly different instructions when you do this in the lab, but the principles will be the same. First of all, a small piece of cotton wool is placed in the bottom of the column to prevent solid material from going into the tap. Different columns may have different types of tap, but obviously the idea will be the same. Next, a small amount of sand is poured in to a depth of about 1 centimetre. Here you can see the sand forming a level surface on top of the cotton wool. We then take the appropriate amount of silica in a beaker, and this is then made into a slurry using the solvent we're going to run the column with. This solvent is known as the eluent. Here you can see us swirling the silica with the solvent before pouring it into the column very carefully. Again, a funnel should be placed in the neck of the column to assist with pouring. And you will need to occasionally swirl the beaker to ensure that the silica doesn't settle out in the bottom of the beaker. Where appropriate, more eluent should be added to reform the slurry to assist with pouring. You may need to do this several times. Should the level of the eluent get close to the top of the column, then some of it should be removed by opening the tap. We can run this into the beaker, which will then assist us in making a slurry with the remaining silica. And finally, we've transferred all of our silica into the column. Now we need to run some of the eluent out of the column so that it comes down to the level of the silica. It's crucial that you don't allow the silica to run dry, so you need to keep a close eye on the level of the eluent and close the tap at the appropriate moment. Here you can see we've run the eluent down to the correct level so that the top of the silica has not dried out. The next stage is to load our crude compound onto the column. First of all, we need to dissolve it in a small amount of the eluent. It's important to ensure that all of the crude compound has been dissolved. And then the resulting solution can be added to the column using a glass pipette. Here you can see the solution is being added evenly around the sides of the column. Now we add some sand to a depth of about 1 centimetre on the top of the column. This will protect the silica as we add eluent. And here you can see us topping up the column with eluent. And we're now ready to run our column. So we open the tap at the bottom of the column, and this allows us to collect our first fraction. In this case we're collecting the fractions in test tubes, but depending on the size of your column you may use sample vials or even conical flasks. Once collection is complete, we can close the tap momentarily to move on to collect fraction number 2. This process can be repeated any number of times to collect as many fractions as are required. Because our compound is coloured in this case, we can actually see it moving down the silica. This will give us a good indication as to when it's actually eluting from the column. In cases where you can't see the compound because of any colour, you can use TLC to analyse the fractions to identify the presence of different compounds. And as the level of the eluent approaches the sand, it's important to make sure that you top it up. We can then continue to collect fractions, and in this case you can see that the yellow band in the silica is approaching the bottom of the column. If we look closely at this particular fraction, we can see that the solvent has a yellow colour, telling us that our compound is eluting. Of course, in other cases, as mentioned previously, you'd have to use TLC to identify the presence of the compound. And here we have a full set of fractions. We can now collect any compounds that are present by removing solvent, and this would most commonly be done using a rotary evaporator.
I hope you have enjoyed watching that video and you have understood how column basically works. There are a few important things you should keep in mind while choosing stationary phase and mobile phase, because the choice of stationary phase and mobile phase will determine how good you are in choosing the column or running the column. So stationary phase, or you say adsorbent, there are different types of stationary phase. It can be acidic, basic or neutral. Usually silica is acidic, alumina is basic, and salicylic acid is again acidic. Even basic alumina, acidic alumina, neutral alumina, this type of alumina are also there. Not acidic, mainly basic and neutral alumina. So depending on the nature of the chemical mixture you should use, you should think what kind of stationary phase you are going to use. But remember one thing, in most of the cases, silica gel column chromatography is widely used. In most of the cases, it is used. Why? Because silica gel you can turn it into basic by treating with tricarmine, or to some extent you can make it neutral, or you can leave it as acidic. So silica gel you can modify to some extent and convert it into other form. That's why most of the chromatographic techniques, column chromatographic techniques, use silica gel as the main stationary phase. Of course, we can use others. And choice of mobile phase. This is very important before running the column. What kind of mobile phase you are going to use? So you should set up the mobile phase based on TLC. Before running any column, you should run the TLC first. Suppose you have one chemical mixture. You want to separate it after the reaction, you want to purify it. This is a reaction mixture. You have run the TLC up to this solvent front, and now after running, you have three components. Please note that TLC you may not get this very good separation of need three components. They might merge, so you may have to come across all these problems. Then you should optimize the mobile phase so as to get a better TLC. After getting a better TLC, you should proceed. So you have three components: top one, middle one, and lower one. Now we have visualized using TLC. Now you can set up a column. Now you can go for column chromatography. So what happens in the column chromatography? Notice this is a normal phase column. It's not reverse phase. So in the normal phase column, top spot comes first here. If I say 1, 2, 3, after loading and eluting it, 1 comes first here, then 2, then 3. This is the way it goes. See, remember, this is anti-gravitational, this is gravitational. So this is taken upwards and this will be put downwards like this. So you take this and put it down here. So that first one will come first, then second one, third one. Or the top spot will come first here, then the second spot, then the bottommost. So if suppose these spots were distinct like this, then no problem. You can start with what you have in the TLC solvent. Similar combination you can use here. But if they are overlapping, suppose, if they are not well separated, if they are not distinct, suppose this reaction mixture, after running, there were 2 spots, we are separating only another mixture wherein they are overlapping. Then separation, sudden separation or column chromatography is a bit difficult here. You should make a certain solvent which properly separates it. After that, you should run the column using that combination of solvent. So that is very important. So how you run the column? You start with the low polar solvent. See, when you start, see, this is having low polarity, high polarity and very high polarity out of these 3. So this will come first. So in the low polar solvent. Immediately if you put the high polar solvent, what will happen? All will come down. So low polar solvent, you take out this first, then you increase the polarity so as to take out the second component, then you further increase the polarity to take out the component 3. Another thing you should keep in mind, solvent should go slow. It should not be run very fast. Faster the run, poor the separation. Now coming to the other applications of column chromatography, this we have already seen, separation of organic mixture into pure components. Basically what column is used for. This is symbol of drug impurities. Most of the pharma industries widely use column chromatography technique. They use flash chromatography. Another latest one, I think this last 10 years, industry have been running this. They can use different type of flash chromatography for removing the impurities. It works fast and it works under high pressure. Since it is out of syllabus, I don't discuss that in detail, but you can read it in Google, flash chromatography, combi flash and biotech, they are widely used. And purification of natural products during isolation. Even during isolation from plant extract or from any animal source, when you will be having mixture. So it's very important to purify and then look for their properties, medicinal properties and other thermal properties, etc. And diastereometric separation, see, this is very important. Diastereometric separation. If you have diastereomer, we can separate it using column chromatography. But keep in mind, anisotropic separation is not possible using this column chromatography. Anisotropes, if you want to separate, you need specially designed chiral columns. So it comes under chiral HPLC. It's very costly. One column might cost more than 1 lakh, 1.5 lakh. But diastereomers we can separate here. It can be any cis-cell trans or any stereo diastereomers. So those you can separate. Estimation of drugs in formulation, you can estimate because it's quantitative, you can estimate drugs when you do the formulation. And isolation of metabolites from biological fluids. This is similar to this natural product isolation and purification. Some of the references which you can read for better understanding, and you can go through various videos available online in YouTube. And some of the notes you can read from NPTEL classes developed by Swayam. Thank you for watching.